Bitcoin blockchain state was defined in terms of unspent transaction outputs, UTXOs, and a reference implementation of the wallet application that held the account reference. Ethereum formally introduced the concept of an account as a part of the protocol. The account is the originator and the target of a transaction. A transaction directly updates the account balances as opposed to maintaining the state, such as in the Bitcoin UTXOs. It allows for transfer of value and messages and data between the accounts that may result in the state transitions. These transfers are implemented using transactions. There are two types of accounts: externally owned accounts and contract accounts. Externally owned accounts are EOA, or controlled by private keys. Contract accounts, or CA, are controlled by the code and can be activated only by an EOA. An externally owned account is needed to participate in the Ethereum network. It interacts with the blockchain using transactions. A contract account represents a smart contract. Every account has a coin balance. The participant node can send transaction for ether transfer, or it can send transaction to invoke a smart contract code, or both. Both types of transaction require fees. An account must have sufficient balance to meet the fees needed for the transactions activated. Fees are paid in Wei. Wei is a lower denomination of ether. 1 ether is 10 to the power of 18 Weis. A transaction in Ethereum includes the recipient of the message, digital signature of the sender authorizing the transfer, amount of Wei to transfer, an optional data field or payload that contains a message to a contract, start gas, which is a value representing the maximum number of computational steps the transaction is allowed, gas price, a value representing the fee sender is willing to pay for the computations. Let's examine an actual Ethereum transaction at the following address. Elapsed time values may be different than those recorded at the time of this recording. Observe transaction hash, height of the chain, timestamp, from and to accounts, value transferred, gas limit, gas used, transaction receipt, success in this case, and nonce. This particular transaction is invoking a smart contract. Of course, the smart contract execution incurs fees, and the amount available is specified by the various gas fields. Ethereum block structure has a header, transaction, and runner-up block headers. Block details. This is an actual Ethereum block at the height 4446308. You can actually view this particular block at the link given. It shows the height, timestamp, block hash, previous hash, difficulty and total difficulty, size, gas used, gas limit, nonce, and block reward. Summarizing, accounts are basic units of Ethereum protocol, externally owned accounts, and smart contract accounts. An Ethereum transaction includes not only fields for transfer of ethers, but also messages for invoking smart contract. An Ethereum block contains the usual previous block hash, nonce, transaction details, but also details about gas or fees limits, the state of the smart contracts, and runner-up headers that we'll discuss later. For a simple ether transfer, the amount to transfer and the target address are specified along with the fees or gas points. The amount and the fees are transferred to their respective accounts. Here we illustrate a transaction of 100 ether transfer between the senders and receivers accounts. Note that besides this transfer, 21,000 gas points are paid to the miner who added the transaction block to the blockchain. As discussed in a separate lesson, an Ethereum node is a computational system representing a business entity or an individual participant. An Ethereum full node hosts the software needed for transaction initiation, validation, mining, block creation, smart contract execution, and the Ethereum virtual machine, EVM. This figure depicts the deployment of a smart contract and the invocation of a smart contract. Smart contract is designed, developed, compiled, and deployed on the EVM. There can be more than one smart contract in an EVM. When the target address in a transaction is a smart contract, the execution code corresponding to smart contract is activated and executed on the EVM. The input needed for this execution is extracted from the payload field of the transaction. Current state of the smart contract is the values of the variables defined in it. The state of the smart contract may be updated by this execution. Result of this execution is stored in the receipts. A blockchain maintains both the state hash and the receipt hash. We'll elaborate these in a later course on smart contract. All the transactions generated are validated. Transaction validation involves checking the timestamp and the nonce combination to be valid and the availability of sufficient fees for execution. Minor nodes in the network receive, verify, gather, and execute transactions. The invoked smart contract code are executed by all miners. Validated transactions are broadcast and gathered for block creation. The consensus protocol used is a memory-based rather than a CPU-based proof of work. Who pays for all these operations? Validation, verification, and consensus. In the next lesson, we'll explore the incentive model that answers this question. As we learned earlier in Module 1, mining is the process used to secure the network by validating the computations, collecting them to form a block, verifying them, and broadcasting it. Ethereum also uses an incentive-based model for block creation. In this lesson, we'll explore some relevant concept about fee structure and the incentive model. Every action in Ethereum requires crypto fuel or gas. Gas points are used to specify the fees instead of Ether for ease of computation using standard values. Gas points allow for cryptocurrency independent valuation of the transaction fee and computation fees. Ether as a cryptocurrency varies in value with market swings, but gas points do not vary. Ethereum has specified gas points for each type of operation. A mining process computes gas points required for execution of a transaction. If the fees specified in the gas point in the transaction are not sufficient, it is rejected. This is similar to mailing a letter with insufficient postage. The letter will not be delivered if it had insufficient postage. The gas points needed for execution must be in the account balance for the execution to happen. If there is any amount left over after the execution of a transaction, it is returned to the originating account. So far, we looked at the gas-related items in a transaction. Now let's look at the gas-related items in a block. Gas limit and gas spent. Gas limit is the amount of gas points available for a block to spend. For example, if a block specifies a limit of 1,500,000 units of gas and a basic Ether transaction fee is 21,000, this particular Ethereum block can fit about 70 plain Ether transactions. If we add smart contract transactions also into this block, that usually requires more gas and the number of transactions for this block will likely be lower. Gas spent is the actual amount of gas spent at the completion of the block creation. Now let's look at the mining incentive model. The proof of work puzzle winner, miner, that creates a new block is incentivized with the base fees of 3 ethers and the transaction fees in Ethereum blockchain. The winning miner also gets the fees, gas points, for execution of a smart contract transactions. That there may be other miners who also solve the puzzle besides the winner. These miners who solve the puzzle but didn't win the block are called omers. The blocks created by them are called omer blocks. These are added as omer blocks or side blocks to the main chain. Omer miners also get a small percentage of the total gas points as a consolation and for network security. Summarizing, any transaction in Ethereum, including transfer of ethers, requires fees or gas points to be specified in the transactions. Miners are paid fees for security, validation, execution of smart contract, as well as for creation of blocks. We presented a high-level view of Ethereum blockchain. We'll use Ethereum as the reference blockchain in the next 2 modules and the following 2 courses.